So now that we have learned a few different methods for solving a quadratic equation, we're going to move on to another method, which is using the quadratic formula. So we have looked at graphing quadratic equations and finding the solutions there, solving with square roots, and solving with factoring. But now we're going to look at the method that is probably most commonly used, and that's because it works with every single quadratic equation. Graphing works best for some. Square roots really only work when it's a very simple equation with no b value. Factoring works when the quadratic is able to be factored. And so they all have their pros and cons, but the quadratic formula always works. Now for today's notes, we're not going to do the whole formula, but we will talk about it. So the formula is this. For a quadratic, for a polynomial in the form ax squared plus bx plus c equals 0, the quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a large formula, but for today's notes, we're just going to focus on this part right here, the part inside the square root, that b squared minus 4ac, and it's known as the discriminant. Okay, and what it does is it separates the quadratic equations into three different types based on its value. So if the discriminant is greater than 0, the equation has two real solutions, so two numbers. If it's equal to 0, the equation has one real solution. And if it's less than 0, if it's negative, the equation has 0 real solutions, but it does have two imaginary solutions. So if you remember from the lesson on square roots, when you have a negative inside the square root, you'll get an I in your answer, and that is the imaginary number. So for the purposes of this class and these notes, instead of finding our imaginary solutions here, we'll just say, look at the real solutions. It has 0 real solutions. And by the way, if the discriminant is a perfect square, like 81, 16, 36, 25, then the polynomial would be factorable. But if you're using the quadratic formula anyway, once you find the discriminant, you might as well finish that out. So for today's notes, what we're going to do is just look at a few different equations, find the value of the discriminant, and then determine how many real solutions the equation has. Okay, so for the first one, we have x squared plus x minus 30 equals 0. And our first step here is to identify a, b, and c from the equation. And those are the coefficients of each term. So a would be 1. B is also 1. And c, that's that negative 30. So once we find the values of a, b, and c, we can then find the value of the discriminant, which again is b squared minus 4ac. And from there, it's just a matter of plugging in the numbers that we know into this little formula. So b from above is 1. So b squared would be 1 squared. Minus 4 times a, which is 1, times c, which is negative 30. All right, and then we just do that math. 1 squared is 1. Think of that as a negative 4. Negative 4 times 1 times negative 30 is positive 120. And 1 plus 120 is 121. So now that's the value of our discriminant. And we know from the notes above that if the discriminant is positive, the equation has two real solutions. So how many solutions do we have here? 2. Okay, so that's what we're focusing on in these notes today, is just using the value of the discriminant to determine how many solutions the equation has. For example B, we have x squared minus 10x plus 25. Our a value here is 1. The b value is negative 10. And our c value is 25. Remember, just the numbers in front of the variables there. And now we can use the formula for the discriminant to find that. So b squared, that'd be negative 10 squared. Be sure to include the negative sign inside that exponent. Minus 4 times 1, which is a, and then times 25, which is c. So we end up here with negative 10 squared is 100, minus 4 times 1 times 25 is also 100, which equals 0. And again, from above, if the discriminant equals 0, the equation has one real solution. So we know here that our quadratic equation would have one solution. If you remember from the notes on graphing the parabolas, that would mean that we have one x-intercept, which is also means that it would be the vertex, would be on the x-axis. Okay, last one. Example C. We know that A is 2. We know that B is negative 3. And C is 15. Okay, so now we can use our formula. B squared minus 4AC. So b squared, that's again negative 3 inside the exponent. Include that negative when you square it. Minus 4 times 2 times 15. So negative 3 squared is 9. Minus 4 times 2 is 8. And 8 times 15 is 120. We end up with negative 111 here. And again, from above, we know that if our discriminant is negative, less than 0, the equation has no real solutions. So for now, we can just say no solution. If you want to make that to distinguish that, you can say no real solution. If you want to make that distinction there. But for our purposes, no solution works just fine. So there you have it. Use the values from the equation, a, b, and c, to find the value of the discriminant, b squared minus 4ac, and then use that value you get for the discriminant to determine how many solutions your quadratic equation has.